GCSE Physics boosters, and this video is about fission and fusion. You need to know a little bit about fusion. Saying that, this topic is just for the physics GCSE, for these separate sciences, not for the combined. Now, nuclear fission is what happens in a nuclear power station. There's one pretty close to me at Hartlepool. Nuclear fission. It produces heat energy, and then that heat energy you make electricity with it. And in 2020, which is last year, 21% of the UK's electricity came from nuclear power. Okay, the fuel that it uses is an isotope of uranium 235 it is. Sometimes they use plutonium in a certain type of reactor, but nearly always it's uranium 235. And you get that from uranium ore, which you dig out of the ground. There's some countries around the world which have uranium ore. Now, that's a nucleus of uranium 235, and it is unstable. And it's unstable because it's very, very big. Okay, there is a limit to how big nuclei can be. And when they get so big, it's at A level, we talk about something called the raindrop model, the water drop model. You can only have a drop of water a certain size. Above that, it's unstable. Now, it's unstable, but it's actually got a very long half-life, about 700 million years. So if you're waiting for it to decay, you're going to have to wait a long time. You can encourage it to decay by giving it another neutron. And if you give it another neutron, it's going to become uranium 236. And uranium 236 is very unstable. And almost immediately, that will decay and it explodes. It explodes into a couple of big pieces, two fragments, and you get 2 or 3 neutrons given off, and you get a lot of gamma radiation. And it's an explosion. So all these bits and pieces have got lots and lots of kinetic energy. And that is a fission event. That's what happens. Fission means breaking in two. A fissure is a crack. So it cracks open, the whole thing explodes. Now, one thing to note is, where does this energy come from? Well, the mass before, the total mass, is a little bit bigger than the total mass after. Now, why? Well, there's an equation you may have heard of, E equals mc squared. And what happens is that a little bit of mass changes into energy. E equals mc squared, thanks to Albert Einstein. Okay, a small amount of mass has been transferred into a lot of energy. In a nuclear power station, what we want to happen then is called a chain reaction. I told you that 2 or 3 neutrons are produced. Well, what could happen is that one of these neutrons, one or more of them, might actually be absorbed by another U235. And so that splits open and that gives off a couple of neutrons, and then 1 or 2 of them go and cause another event, and that produces another couple of neutrons, and you get this thing called a chain reaction. You need to explain this. You might have to sketch a diagram that looks a bit like this. So a chain reaction, the neutrons produced, but not too many, go on and cause further fission events. And you control the whole thing using things called control rods. And what the control rods do is they gobble up neutrons, they absorb neutrons. So if you want to slow the reaction down, you lower the control rods into the reactor and it gets rid of neutrons, and that slows the reactor down. If you want to speed it up, then you pull them out of the reactor and everything speeds up again. So when a chain reaction is happening, the reactor gets very, very hot because you've got all these fragments and neutrons whizzing around very, very fast. and so it's heat energy. It gets very hot. So you take the heat away using a coolant. There's different types of reactors. Some of them use carbon dioxide, some of them use pressurized water, or you can have liquid sodium. There's different types of reactor. But then the coolant, which is very hot, then they use that to heat up water to make steam in a boiler. And then that steam goes through a turbine connected to a generator and makes electricity. Now, I said we don't want too many of the neutrons to cause other events. If you've got more than a couple of neutrons from each event causing another event, then you're going to get like an exponential. It's going to get bigger and bigger and bigger in a very short amount of time. Lots and lots of energy released, and that is a nuclear explosion. This photo is Hiroshima, the bomb that went off at the end of the Second World War. And that's the bomb that did it. Well, no, it's actually a model of the bomb that did it. They still haven't got the original bomb. Called Little Boy, it's called. Had 63 kilograms of uranium-235 in it. Now, fusion. We've talked about fission. Fission is breaking into bits. Fusion is sticking together, fusing. And this is what happens in stars. This is what's happening in the core of the sun. And this is lighter elements fused together to form heavier elements. And just as before, a little bit of mass changes into energy. Yes, the mass of what you end up with is a little bit less than the mass of what you start with. And E equals mc squared, lots of energy is released. Okay? Now, what actually happens in the sun is quite complicated. It's called the proton-proton chain. You don't need to know it. If you just say that hydrogen fuses into helium. So in our sun, hydrogen is fusing into helium. It would be very nice if we actually got fusion working on Earth. If we could get fusion nuclear power stations to produce large amounts of electricity, then it's virtually renewable. There's much less nuclear waste, and it's a lot less dangerous. And an awful lot of scientists are working on this at the moment, trying to get fusion reactors working on Earth. And some say we're not that far away.